Well, that's interesting. The pencil for this is not here. So I guess I'll just use my pencil. Where'd you find it? Oh, thank you. Thank you. Okay. So, what we are going to do today, you guys, is a couple more proofs. And we're going to add a step to it that does make it a little bit difficult. Okay? So the first thing, when we look at this proof, let's go ahead and add the givens. This particular proof does not have the extra step that I was talking about. So here it says DE and BC, and bisect, I always just use BIS for each other. And that is given. Okay? Now, when you have bisectors, on your cheat sheet there already is one for segment bisectors, and then we added one yesterday for angle bisectors. When you have a segment bisector, it just says it cuts that segment into two congruent parts, okay? In this one, they're saying DE and BC bisect each other. So that means they cut each other in half. So what you could say there then is that this side is congruent to that, as well as BG is congruent to GC, because they cut each other in half. So we would go down and we would say DG is congruent to GE, as well as BG is congruent to GC. Which is, so here we bisected a segment. Yesterday we bisected an angle. When we bisect a segment, it's definition of segment bisector. And you can just do SEGBIS. So in these, sometimes you're bisecting an angle and it's definition of angle bisector. Sometimes you're bisecting a segment and its definition of segment bisector. Okay, now what we're gonna do is look at these two triangles and see if there's anything else.
Would they be vertical?
Vertical angles, very good. So whenever you have two straight lines that intersect, you wanna look for vertical angles. And here we have to use 3 letters, so we can say angle BGD, angle BGD is congruent to angle, and you could say EGC or CGE. EGC, okay, and that is vertical, VERT, then you can do the angle symbol, and then THM for theorem. Okay, then we can copy down our proof statement. So we can say triangle DGB is congruent to triangle EGC. Okay, And right now, we know two different shortcuts ways. We know side, 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 and we know side, angle, side. This one has an angle, so it can't be side, 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 and it is side, angle, side. So we would write that right here. Okay? So now we're gonna look at what that extra step is. So if you look at the proof we just did and everything we did so far this section, we were always trying to prove two triangles congruent, okay? There are proofs that are gonna be coming up and what's on your homework today where they're not just asking you to prove the two triangles congruent, you still have to show the two triangles are congruent. So maybe this is A, B, C, and this is D, E, F. And let's say you prove these two sides congruent, these two angles congruent, and these two sides congruent. If you did that, you can say those two triangles are congruent by side, angle, side. So you'd have a step then that would say triangle ABC is congruent to triangle DEF, okay? And that would be by side, angle, side. But then what happens instead is that we have something else that's congruent, okay? And when we look at that, instead of just asking you to show that the two triangles are congruent, they're gonna ask you that either an additional side or an additional angle is congruent. Once you show these triangles are congruent, you could say AC is congruent to DF, or you could say angle A is congruent to angle D, or you could say angle C is congruent to angle F. And how these proofs are different, they would ask you to prove a set of sides are congruent or a set of angles are congruent. So let's say that they wanted us to say angle A is congruent to angle D. The reason for that is called corresponding parts of congruent triangles are congruent. And sometimes you have to write that whole thing out, but people, geometry teachers, I guess, have come up with an abbreviation for this. So instead of writing the whole thing out, what we do is we write out CPCTC. So that would be our reason right here, okay? Now that even can be hard for kids to remember. You could write that on your cheat sheet, but otherwise what happens is we have kids think about what is a school appropriate saying that starts with those letters. And I always use the one, I'm not sure why, that is chubby pigs can't talk Chinese. Okay? That's how I remember CPCTC. Okay? So if you want an extra credit assignment that you can work on, and maybe we'll make it due like next week, Wednesday, you can take just a plain sheet. I have some plain printer paper, and you can just write down CPCTC and come up with a school appropriate saying for that. Okay, I'll just show you a couple that my high school kids just did. To get 10 extra credit points, you have to have color. You don't have to color the whole page, you just have to have color. You have to have a school appropriate saying. Saying doesn't have to make sense. Like when you look at mine, that doesn't make sense. But something that's gonna help you with that. So I'll just show you a couple. Country people control tractors carefully. Cold pools cause trembling children. Chubby puppies chew toys crazily. Crazy people count turkeys carefully. Cute that pangolins? Do you guys know that animal? Can talk Cantonese. Clever panthers can take cell phones. So it doesn't have to be like the best art ever, okay? I can't draw, so I don't expect you guys, just have some color, have a saying that's school appropriate, and then turn that in by next Wednesday and you get 10 extra credit points, okay? All right, so again, how you know if you have to use that step is when your proof statement is that angles are congruent or sides are congruent, okay? So here we're gonna write down our given. It says AL bisects angle FLE, and FL is congruent to EL. Okay, and that is given. All right, so now what I'm gonna do is go to my page here and I'm gonna mark that FL is congruent to EL. Okay, that's given. And now I wanna look at what else do I have to do here. And it says AL bisects angle FLE. So it cuts the angle in half. And so the two angles that would be congruent are those two right there. AL bisects this angle. So my second step then is going to be angle FLA is congruent to angle, and I could either say ALE or ELA. Doesn't matter which way you do that. And when we say that, this one we bisected an angle, so it'd be definition of angle bisector. Okay, now do you guys see something else that's congruent?
L-A-L.
Yes, this is reflexive, so we can say AL is congruent to AL. And I was talking yesterday about if you have two steps, like step 2 and 3 here, which one you do first does not matter. So 2 and 3 could be in the opposite order too. Now this is what makes this one a little bit harder. In the proofs we've done so far, they told us what two triangles are congruent, and here they're not, okay? So what you have to do is you have to write that congruent triangle statement by yourself. So here's what I do, okay? When I go to write this, in this one I have a side with 1 dash and a side with 2 and a side with nothing. So when I go to name this, I'm gonna just write it here for now. I would say triangle F, I'd go along the side with 1 dash, then 2, then none. So I'd say triangle FLA. So I went along the side with 1 dash, then 2, is congruent to, and then here I'd have to do that same order. So I'd go along the side with the 1 dash and then the 2. And that would be ELA. Now, if yours was a little different here, as long as F and E line up, L and L line up, and A line up, you're fine. But this is not the only way you could write that, and that makes it a little bit more difficult. So now we're gonna say triangle FLA is congruent to triangle ELA, and that is by, is it SSS or SAS? Yep. So we'd say SAS, but we're not done, because if you remember, what we want to do is prove that angle F is congruent to angle E. So now, after I show my triangles are congruent, I can say angle F is congruent to angle E by CPCTC. So you still have to show the triangles are congruent, but then you're gonna have one step after that. That's the CPCTC. Okay? All right, now let's go here and let's write down our given. X is midpoint, I always do MIDPT of BD, and X is MIDPT of AC, and that is given. Okay, now when they give you a midpoint, you're gonna have to have what step in your proof? Do you remember? Midpoint theorem, right? Midpoint theorem. So they're saying X is the midpoint of BD. That makes this congruent to that. Then they say X is the midpoint of AC. That makes this congruent to that. Okay? So that's what we're gonna write down next. If that's the midpoint, we can say DX, segment DX, is congruent to segment XB. And then segment AX is congruent to segment XC. And whenever you have a midpoint, that means you're gonna do midpoint theorem. Okay? Now, they're asking us to prove, and you can kind of cheat on this one. It tells you which triangles we're wanting to prove. We're wanting to prove that these two are congruent. Okay? Do you guys see something else that's congruent there? The vertical angles again, very good. So angle DXC right here is going to be congruent to angle AXB right here. So I'm going to say angle DXC is congruent to angle AXB, and that is by the vertical angles theorem. Now, if you guys look at what we're wanting to prove, do we have to do that extra step for this one? We don't. It's only if you're trying to show that two angles are congruent or two sides are congruent. So this one, we're just gonna copy that down. So this one's easier. So you're gonna say triangle DXC is congruent to triangle BXA by, and this one is what? Isn't it side angle side? Side angle side. Okay. All right. We have just one more. Okay, so let's look at this one. And here we're going to write down our given. So let's do that. We have segment RQ. What do those two vertical lines mean? Parallel, yes. Okay. And then we have that RQ is congruent to TS, and that is given. Okay. Now, one question I get a lot, you guys, when we're trying to figure out is it angle, side angle, or I'm sorry, side angle, side, side. You can't use parallel lines when you're doing that. it has to be congruent lines that you're using. If you're trying to do side angle side, you can't use the arrows for that, but you can use the side markings for that. So now, do you guys remember what I said when we look at parallel lines, what kind of angles do we want? Alternate interior. And this is tricky, so please watch this. If these are the two parallel lines, and this is my transversal, okay? The two angles I marked are the ones that touch the parallel lines. So these are the two that are congruent and alternate interior. When you mark it, you touch the parallel lines. Now we're gonna have to use 3 letters, so we're gonna say angle QRT is congruent to angle, let's see what that is, STR or RTS, so T would have to be in the middle there. And those are alternate interior angles, so it's called alternate interior angles, and then you have to add theorem at the end. Okay? Now, does anyone see something additionally that's congruent here? The reflexive property right there, okay? So I can say RT is congruent to RT. And that is reflexive property, okay? Then, do I have to do the extra step in this one? Yes. So, like I said, when you're going to do that part, you have to show the two triangles are congruent first. So, if I was doing that, I would go along the side with 1 dash and then the side with 2 dashes. So I would call this triangle QRT is congruent to, and when I go to do the other one, I do the same thing. Along the side with 1 and then 2, so that'd be STR. Okay, so I'm gonna write that down. So it's triangle QRT is congruent to triangle STR. And that is by side angle side, side angle side. Okay? All right, are we done? Don't we still have to write this down? So I can say angle Q is congruent to angle S. And that is by the chubby pigs can't talk Chinese, okay? So your assignment today is a worksheet. There's 6 problems. Okay, so I'll get that for you. And I do have a key up here for the 6, and I believe I put it in Schoology also. Did you guys see that I put yesterday's key in Schoology also? You can work with a partner today, okay?
Thank you very, very much.
But you have to work, try to get this done.
Yeah, Elliot, let's take it actually.
Oh. Just make sure you put your desk back nicely when you're done.
Take one. You need one.
In the right place.
Yeah.
And you want to say Grace? Grace, I don't think it's her name.